Paper number 104, Differential Equation, myself Hardik M Pandya. Classification of linear partial differential equation. A second order linear partial differential equation A into uxx plus b into uxy plus c into uyy plus d is equal to 0, where a, b and c are function of x and y and d is function of x, y, ux and uy, is classified based on b square minus 4ac as follow. B square minus 4ac is less than 0, then it is elliptic. B square minus 4ac equal to 0, then it is parabolic. And b square minus 4ac greater than 0, then it is hyperbolic. Example of classification of linear second order partial differential equation. Example, heat equation, alpha into del square u upon del x square. This is u xx minus ut equal to 0. So here a is equal to alpha, b equal to 0 and c is equal to 0, implies b square minus 4ac is equal to 0 minus 4 into alpha into 0, so it is equal to 0. So heat equation is parabolic. Wave equation, c square into, this is uxx, the coefficient of uxx is equal to c square, so a is equal to c square is greater than 0, and uxt, the coefficient of uxt is equal to 0, and the coefficient of utt means utt is equal to del square u upon del t square, and the coefficient of utt is minus 1, so c is equal to minus 1, implies b square minus 4ac, put the value of abc, 0 minus 4 into c square into minus 1, so minus minus plus, and for c square is greater than 0 because c square is greater than 0, so b square minus 4ac greater than 0, so wave equation is hyperbolic. Del square t upon del x square, so a is equal to 1, and del square t upon del y square, so c is equal to 1 and b is equal to 0. Put the value a b c in this, b square minus 4ac equal to minus 4 less than 0, so it is elliptic. Now next topic, Rodrigue formula. Pn of x is equal to 1 upon 2 raised to n into n factorial into nth derivative of x square minus 1 raised to n with respect to x. Proof. Let y is equal to x square minus 1 raised to n. Now differentiating this with respect to x, we get n into x square minus 1 raised to minus 1, and derivative of x square minus 1 is equal to 2x. So we get 2, 2nx into x square minus 1 raised to n and x square upon x square minus 1 upon so this is equal to y, and we can write dy by dx is equal to y1, and this term x square minus 1 and minus 2n xy is equal to 0. We get equation number 2. Now differentiating equation 2 n plus 1 times using Leibniz theorem, so we get yn plus 2 into x square minus 1 n plus 1 times differentiating, so yn plus 2 into x square minus 1 plus n plus 1 c1, nc1 is equal to n, so n plus 1 c1 is equal to n plus 1 into yn plus 1 and derivative of x square minus 1, so 2x plus nc2, so nc2 is equal to this and yn and derivative of 2x is equal to 2, and next nc3 into yn minus 1 into derivative of 2, so we get derivative of 2 is equal to 0, so remaining terms are 0, and now minus 2n into yn plus 1 into x plus n plus 1 c1, so n plus 1 c1 is equal to n plus 1 yn and derivative of x is equal to 1, so and in the next term derivative of 1 is equal to 0, so remaining terms are 0 equal to 0. Simplifying this equation, we get yn plus 2 into x square minus 1 plus 2x yn plus 1 minus n square plus n into y is equal to 0. Now common out minus sign, we get 1 minus x square into yn plus 2 minus 2x yn plus 1 plus n into n plus 1 yn is equal to 0, which is equation number 3. Now we put the value yn is equal to v, so yn plus 1 is equal to first derivative of v with respect to x, and yn plus 2 is equal to second derivative of v with respect to x, d2v upon dx square, and yn is equal to nth derivative of dn upon dxn into x square minus 1 raised to n. This is yn is equal to v. Next 1 minus x square into d2v upon dx square minus 2x dv by dx plus n into n plus 1 into v is equal to 0, which is Legendre's equation, and the solution of this equation is v is equal to a into pn of x plus b into qn of x, and but since v is equal to yn and yn is equal to this is only positive power of x, This contains only positive power of x, so solution can only be constant multiple of Pn of x. So Pn of x is equal to constant into V is equal to C into Yn. C is constant, put the value Yn is equal to this. But x square minus 1, but x square minus 1 is equal to x minus 1 and x plus 1 raised to n. So we can write x minus 1 raised to n into x plus 1 raised to n, and we can write dn by dx raised to n is identically d raised to n. So c into dn into this. Now differentiating this by Leibniz rule, we get this, and simplifying this, simplifying this, we get c into n factorial into x plus 1 raised to n plus n into n minus 1 up to 3 2 into x minus 1 into n x plus 1 raised to n minus 1 plus up to x minus 1 raised to n into n factorial. Now taking the value x is equal to 1 on both the side, we get Pn of 1 is equal to c into n factorial into 2 raised to n plus 0. Put the value 1 minus 1. So this term is 0. And the value Pn of 1 is equal to 1. So the value of c is equal to 1 upon 2 raised to n into n factorial, and the value c is equal to 1 upon 2 raised to n into n factorial put in the equation number 4. In the equation number 4, the value c, so we get Pn of x is equal to 1 upon 2 raised to n into n factorial into nth derivative of x square minus 1 raised to n with respect to x, which is Rodrigue formula, and using this formula, putting the value n is equal to 0 1 2 3 4 5, we get these results. Thank you.